Okay, good evening. Today I want us to continue with the derivatives. Then on the previous session, we're doing the derivatives from the first principle. So today we're continuing the derivatives, but not from the first principle. So on this one, we just derive the given information using the formula or the principle that we know, but not the first principle formula, not that one. Okay, let's see here. We're having some rules that we have to go through. The rules of derivative. Now on the rules of derivative here, I will just take one or two of them, and then so that we can understand what are they meaning when they say so. Okay, before you can differentiate, we differentiate and we derive, which is the same thing in most cases when coming to grade 12. But going higher, you will realize or differentiating and deriving is not the same statement. They said the first point here, say finding the derivatives using the rule of differentiating. So it means basically here we are differentiating. When we differentiate, before you can differentiate, you might need to, the first point, they say expand the brackets because you have no rule for differentiating a product. You have no rule for differentiating a product. The second one, they say that rewrite the terms which are square roots and also the cube roots and the other rules as exponential so that you can use the rule so it means when you cannot derive if your term has the exponential form or the numbers. Now, not exponential, but the cubic square root and also other roots. Now rewrite the terms which are fractions. So when you rewrite the term which are fraction, so that you can use the power rule. Rewriting the terms that are fraction, writing the terms that are fraction is also important here. Make sure that you understand what do they mean when they say rewrite terms which are fractions. So which means if they are fractions and then the x that we are looking for is at the denominator, rewrite it to be on the side be multiplying, having the coefficient multiplying. Now take note of notation we use for the derivative. Now for those ones, we come back to the formula. If no matter how many terms are there in a given statement, so we will start by saying that if it's a term that is given, let's say it's x to the power of n, it's x to the power of n, and then when we derive our simple formula or the simple rule we will use, which will be equals to, we will be having something like here x is our what is it, x is our base, remember, or we derive mostly the exponent. X is our base, and then if x is our base and then n is our exponent, here, n is our exponent. So the rule of power, it says that the differentiating rule here, it will say that the exponent itself, but before we go that, there is a coefficient of m. If there is no number, it means it's 1, but I'll just represent the coefficient of a base by m. If there is nothing, it means it's 1, but if a certain value, it has to be in this way. This m, it can be in the form of fraction. Let's say it's 1/2, then it has to multiply the base x, and then here the rule of differentiating is going to state in this way, or we're going to differentiate is in this way. We're going to say the exponent, which is n, and then multiply by the coefficient of the base, which is m, and then multiply by the x, which is the base, and then to the power of n as an exponent, yes, and then the exponent we minus it by 1. So the exponent that we minus it by 1, so that we can get to the answer. This is the principle, or this is the rule that you'll be using to differentiate all the terms. So if means, for example, it is, let's say for example, we have 2x to the power of 3, 2x to the power of 3, 2x to the power of 3, and then plus. You see now it's plus. So if it's plus, let's say it's plus x. it's plus x. So it means on our given expression, we are having two terms. Term number one, which is this whole thing. Term number two, which is this whole thing. So which means if there is no exponent given on the x here, it means that the exponent is 1. So what we derive on the x in most cases. So when we are going to derive this one, you will use, make sure that your equation or expression is in the standard form, is in the form of an exponent. Yes, it's in the form of an exponent. Then I will say 2 as the coefficient of x. I will multiply by exponent. So I will have 3 multiplied by 2. 3 multiplied by 2, which is the exponent multiplied by the coefficient. And then x, I will just write x as it is. I'll just write x as it is. And then I will have x. And then my exponent, which is 3, I have to minus it by 1. I have to minus it by 1. And then that is the first part I have. I'm deriving the first part. And then again, I will say plus, which is the second part. Then here there is nothing. It means there is 1. So if there is 1, I will put 1 multiplied by 1. 1 multiplied by 1 to the multiply by x again. X to the power of x to the power of 1 minus 1. So the same exponent here, it multiplies the coefficient here, and then it be minused by 1. Then simply, the next step, we're going to say 3 times 2, which is 6. Then we will have 6x. 6x will be having something like 6x. And then on our 6x, it will be 6x to the power of 3 minus 1, which is 2, then plus 1 multiplied by 1 is 1. And then on that one, we'll say x to the power of 1 minus 1, which is 0. Then x to the power of 0. Anything to the power of 0 is 1. So it's going to be 1 multiplied by 1, which is 1. So from here, we have derived, we are done. There's no need of deriving any further. Up to so far, we have derived, our expression derived is 6x to the power of 2 plus 1. Then that is how they mean with this information here. Okay, so I want us to go into reality. Let's go to the problems. The problems can be given into 3 ways. In the 3 ways that it can be given to you, I just want us to look at the first one. Let's say determine the G prime of the following. Which means now G is our standard equation. Standard equation, or is the form of, or is the what is it? In other words, okay, I forgot that word I want to use. Okay, the first one, which is G x is equals to 2 over x to the power of 2. Now it is given in a form of a fraction. So the first thing what we have to do here, we will have to remove the fractions. Okay, let's go back to the screen on the writing pad. Okay, now coming back here on the writing pad, we derive this. So when they say determine G to the power of 1, it means holding the first derivative of this whole thing. And then the first thing that you must have, check how many terms do you have on the equation given. This is just only one term because it multiplies itself. And then now we must get rid of the x from the denominator to the top. So which means we will use the thing of multiplying the exponent by minus 1. And then we will have 2 multiplied by x to the power of minus 2. Or how do we get minus 2? We will have 2 into brackets multiplied by minus 1. That's how we get rid of this x to the power of 2 from the denominator, which will be simple 2x to the power of minus 2. So which means we didn't derive. We just make sure that we get rid of this thing in a standard form so that we can now start deriving. Then after you do this thing, you derive. Then how do we derive? The same thing that we were talking about, the exponent, which is minus 2, then I will have minus 2 multiplied by the coefficient of x, which is 2. Then x as it is, I rewrite it, and then the exponent as it is, I rewrite it, and then I minus it by 1. So the same exponent, it has to multiply the coefficient, and also it has to be minused by 1 up there. And then simply mathematically, so we will have minus 4, because 2 multiplied by minus 2 is minus 4, and then x as it is, then minus 2 minus 3 as an exponent, sorry, minus 2 minus 1 as an exponent, it will be minus 3. So which means simply our derived part we are done here, which is minus 4x to the power of minus 3. We are done deriving. So in most cases, they say leave your answer in a positive exponent. In a positive exponent, it means we have to take x to the power negative 3 as denominator, which means the coefficient of this x, it becomes the numerator. So we will have minus 4 as a numerator divided by x to the power of 3. So now the base of this x is just the space as it is, and then the exponent of this x, if it was negative, now it becomes positive. You see, where are we going? That's where it comes from. So this is a positive exponent, and we didn't derive further. So the same equation, this one and this one, they are both equal, but this one is in positive form or positive exponent, while this one is in negative exponent. So always they will tell you to leave your answer in positive exponent, which means it has to lead you to this part. Let me give you just a minute so that you can go through. Good. Let's continue and see the second information. The second information. Now, on the second information that we can be talking about, we are looking at, let me find the one that is more complex. It's still the denominator. The terms are numerator and denominator. Let me take number 2, and then I will take number 4. Okay, let's see. Number 2 is more the same, or is more or less the same as that one. But then let's see how we can do this thing. So we will have gx still again is equals to 2 divided by 3 multiplied by x to the power of 2. Okay, let's see how we can break it down and then bring reality to it. Okay, they say derive. When we derive, we make sure that this is what we want to be multiplying everything. This is what we want to be multiplying. Because we want this to say a multiplied by x to the power of exponent. We don't want a over exponent, x to the power of exponent. We want to get rid of the fraction or x being the denominator. X, it must be multiplying whatever fraction number it is. That's what we mean on that statement of those principles. Okay, now we have to get rid of this, and automatically you know how we get rid of this from the denominator. We have to multiply everything. We rewrite everything as it is, and then we multiply it by x to the power of 2 multiplied by negative, which means now it becomes negative 2. The exponent of x becomes negative 2. So which means now this is the first step of simplifying. We didn't derive, we were just simplifying. We haven't derived yet. Some of you may leave it here by confusion and thinking that it is derived. No, it is not derived. It's how it's supposed to be done. Okay, going further, we go down, then we start to derive. The exponent, which is minus 2, it has to multiply the coefficient of x, which is 2 over 3. Then I will have minus 2 multiplied by 2 over 3. Then everything x to the power of minus 2, the exponent itself, I minus it by 1. That's what we mean here. And then going further, what do we have? Mathematical simplification. Then it's going to be equals to yet multiplied by y, which is going to give us minus 4 over 3, x to the power of negative 3. So which means I'm done deriving. The derivative now it's done. What do I do? And then take it back into positive exponent. Then how do I get rid of x to the power negative 3? I take it as the denominator. I'm going to write it at the position of the denominator, which is, then I will have divided by 3 multiplied by x to the power. It's not going to be negative 3. The exponent now changes to become positive, which is now going to be negative 3. So you see, We just derived it, and then we take it back. That is the final state of the answer that they are looking for. Even if you can leave it in this way, and then while they say leave it as a positive exponent, you might not get the full marks from the question. Okay, good. Let's look at the next one. It's still the fraction, but this fraction it's in another form. Okay, the oh sorry, I'm showing you the wrong screen here. Sorry about that one. I mean to share this one. Yeah, good. And then the next question, these things are the same. And when they are the same like this one, they just need you to understand how we work them. If you can fail to work them or how we work them and how to derive, it's not going to be easy for you. Okay, let me just take the one here. Yeah, minus x over 6, and then also I will go to minus 2 over root x, and then that will be the first example that we will be taking there. Okay, let's come back here. Okay, here I'll start with the first one. It means now here our x is as the denominator, is as a numerator, and I have to remove it as a numerator, and it has to multiply this thing. So here there is nothing. It's more like if there is no number given, it's 1. So it's more like saying minus 1 over 6 multiplied by x. See, I'm removing x here on the position. I'm putting it here so that this whole thing, it can be the coefficient. We cannot, even if you know what to do, but we cannot derive it in this form because we don't know the coefficient so far. So we have to remove it here and it has to multiply here. So it doesn't take any form, meaning the exponent, it's still 1 on it. So we leave it as it is. And then what do? They said that the principle on deriving said that the exponent, if there is nothing, is 1. Then we'll have 1 multiplied by the coefficient, which is minus 1 over 6. Then x to the exponent of 1 minus 1. Then I will have minus 1 over 6 multiplied by anything to the exponent of 0 is 1. And I will have the answer is minus 1 over 6. That's the answer. Here, you are done. Good. The second part, we're having negative 2 over root x. The first thing, get rid of this from the denominator. And then after getting rid of it, change what? Change the square root. But here, before you can change the number from denominator to the numerator, you have to get rid of square root first. Let's see, which is equals to minus 2 divided by. How do I know the exponent of x? Exponent of x is 1, and this is the square root. If there is no number here given here, it means that the number is automatically 2. Then I will have x to the power of 1 over 2. So this is the simple way of get rid of square root. But if it was 3 here, if it was 3 here, it's going to be x to the power of 1 over 3. But now because there is nothing, is a default, it's just 2. Then this equation is, or this statement, it's more like saying minus 2 over x exponent 1 over 2. I haven't derived. So now since I get rid of square root, I have to get rid of this as denominator to the numerator. So I will still do the same thing, multiply the exponent of x by negative. Then I will have minus 2 multiplied by x to the exponent of negative 1 over 2. This is how simply you can write it. And then from here, your equation is in a standard form. You can now derive. Exponent, which is negative 1 over 2, it has to multiply the coefficient of x, which is minus 2. And then the exponent itself, I have to minus it by 1. And then what do I get? Here I will get plus 1, x to the power of minus 1 over 2 minus 1, which will gives you minus 3 over 2. Then simply so, the answer is x to the power of negative 3 over 2. So to rewrite this as a positive exponent, here the coefficient is 1. So I will have 1 divided by, I take it back, I send it back to the denominator as positive exponent. It's 1 over x to the power of 3 over 2. And then the whole thing, which is equals to, what is it equals to? It's going to be equals to, I will have to convert 3 over 2 back to square root. So which means our denominator of the exponent is 2. Then which means it means a square root. Then I will have 1 over square root of x power of 3. That is your answer. Good. Okay, let's go to the next one. Let's go to the next one. Okay, on the next one, I will just simply choose the number E so that you can understand how we get rid of fourth root. We were doing the square root, now we are doing the fourth root. Now these questions are coming in different forms. Remember, these are only one terms. So if there are one terms, it's going to be easy for you. But if there are more terms, it means you have to do the application of changing this one form into another in all the terms, if applicable to all the terms. Yo, okay, then I'm having something like this. Let me just copy it down, and then we'll see where it lead us. Okay, let's come back. Okay, let's solve it and simplify. So I will firstly get rid of this fourth root. How do I get rid of fourth root? I will say 2 divided by, and then remember exponent of x, it's 3. It means I have to divide it by the root here, which is x to the power of 3 divided by 4. That is the fourth root. And then simply I have to get rid of this as denominator to the base, which is equals to 2 multiplied by x to the power of negative 3 over 4. Simple. Then it's done up to here. What do I have to do? What I have to do now, I can start deriving, differentiating. Exponent multiplied by coefficient, I'll have minus 3 over 4 multiplied by coefficient, which is 2, then x as it is, then exponent, I write the exponent as, and then minus it by 1. I'm done. I am done deriving. There's nothing else I have to do from here or in terms of deriving. I just have to simplify. Then this one times this one, 26 over 4, then it's negative there, and then it's going to be x minus u. With a calculator, I will have u times u, which is positive 3, and then positive 3 plus positive 3 minus u times u, which is 4, and then okay, 1,75. 1,75. I don't know how to write 1,75 in an exponent, the whole mathematician. Wow. Okay, it's okay. I will simplify this as it is and then leave it here. I'm not in possession of a calculator. Punch in a calculator and leave it as it is there. They want with you. So yeah, you get to your answer in that way. And then obvious the exponent form, and then you'll have to get rid being negative denominator divide as a numerator divide by 4, and then x will be coming here, and then after being divided by 4, x will be coming here, and then the denominator here, it will be 4, which means it will be giving us the fourth root again here. And then if you punch this thing on a calculator, it gives you the value. Then if it gives you the value, that number, let's say maybe it's minus 7 over 4, and then minus 7 over 4, then the 4 will come here, then the 7 will come here. That's how you take it back into that form. So I'm not in possession of a calculator so far. I cannot change it, but that's how it's going to lead you to the final answer. Okay, let's look at the next part. Now on the next part of these things, the next part. Okay, now interesting. Good. The next part, they still say differentiate. Differentiate, you're finding the first price of the given. Now, the challenge here is that our equation is given or expression is given in more than one terms. You have to simplify it from the brackets to find how many terms are there. So we just do the same breakout or breakdown of everything. This is mathematics. Nothing is changing. We just improve what we learn. So we have in the brackets x to the power of 2 minus of x or the brackets to the power of 2. Okay, let's do it so quickly within a minute. So this is more like saying when we solve for x, we know that we have to square root both sides to be 2. So not square root, we have to square both sides to be 2 of them. So x to the power of 2 minus root of x into brackets, bracket 1, x to the power of 2 minus root of x into brackets. So they are 2. That's what they mean. Then what do we do? Mathematically, we say this one times this one, which will give us x to the power of 4. And then this one times this one. It's more like saying when we multiply the power of the same base, we add the exponent. So firstly, we change root of x. Root of x, it will give us x to the power of 1 over 2. So when we have x to the power of 2 multiplied by x to the power of 1 over 2, when we multiply the power of the same base, which is going to give us negative x to the power of 5 over 2, 5 over 2, which is 2 comma 5. Okay, when we say this one multiplied by this one is this one, then again this one multiplied by this one, it's gonna still be the same thing, negative 5 x power of 5 over 2. Okay, and then the last one is negative root x multiplied by negative root x. So 1 over root x, it's more like, hey, 1 over 2. We have changed it. So when we say 1 over 2, so x1 over exponent 1 over 2 multiplied by exponent 1 over 2. The law of exponents says when we multiply the power of the same base, we add the exponent. We will have half plus is going to be equal to x to the power of 1. So negative times negative is positive, positive x, just like that. And then is our equation so far. Then we rewrite it, we group the like terms, minus minus, it's minus 2, and then minus 2 of 5 exponent, minus 2 of x exponent of 2, then plus x exponent of 1. Then my equation is in standard form. I can start deriving. When I derive the first part, I derive the second part, I derive the third part, which means I have 3 terms. I have to derive all the 3 terms. First term, exponent is 4, coefficient is nothing, which means it's 1. Then I will multiply by 1, x to the power of 4. That's the derivative of the first part. Then I go to the second part. Second part is negative and is 2. 2 multiplied by exponent is 5 over 2. And then I write x, then I put exponent, which is 5 minus it by 1. I have derived the second term. Then I derive the third term, which is plus, and then coefficient is nothing, it's 1. Then x as it x, then exponent go 1, then minus 1. Then I'm done deriving. I will no longer derive. So I derived it term by term by term so that I can get to the answer. That's what they want us to do. Please don't derive more than this. Then from here we simplify. We'll have x 4x 4x to the power of 3, then minus 5. When you multiply this one, it gives you minus 5, and then x as it is, we will have 2 comma 5 minus 1, then it's going to give you 1 comma 5, which is 3 over 5, and then plus anything to the power of 0 is 1, so plus 1. And here we are. If I gotta leave your answer in such form, I will still have 4x to the power of 3 minus 5 fifth root of x to the power of 3 plus 1. This is optional. If they say leave it in the form of or in a SAT, then you will leave it. You will have to convert this. Remember, the the exponent denominator, the number has to be the number of, if it's 5, it's fifth root. If it was 2, just simple square root. If it's 3, then I'll give cube root. It was 4, I will give fourth root. If it's 5, I'll give fifth root. And then the numerator on that it's the exponent actually. So this is how it is done. Take out notes as it is. So be careful. If you fail to understand every step by step here, you are wasting our time. That's where we call the free marks question. Now the free mark questions comes from here. Okay, let's see the next one. In the meantime, let's see the next one. The next one we can look at number J. The second one. On number J, there are a lot of conversions we have to do before. Remember the first one we were simplifying. So now if we can check number K, there are a lot of administration there. Okay, I'll just do number J and K as we wrap up the topic. Then this is the cube root of 8 x to power 18 all in all minus 3 over 4 x to the power of 2. Okay, let's come back to the screen. Coming back to the screen, I'm into the touchpad, the pen board. Okay, we derive. First thing, simplify. We see square root, remove square root. If you see cube root, remove it. So which means that everything under the cube root here, it's multiplied. It has to, the exponent, it has to be divisible by 3 or divided by 3. So which means now it will have 8 itself doesn't have an exponent shown. It means it's 1. Don't ask me where is 1 coming from. Use your calculator and say 8 to the power of 1. It gives you 1. So if you write 8 or a number or as it is in a form of exponent, it's just a letter to the power of 1. So which means going further, what do we have? We are having simply 8 to the power 1 over 3 multiplied by x to the power 18 over 3. So I remove the square root. So you see now, these questions, they don't give you example of them by just saying, well, let's choose. No, they know that some of you will just the cube root only goes to x here and forget to give it because 8 is still underneath. So minus. On the left side, we can remove the x from this part, write the 3 over 4 as it is, multiply by x. Then don't forget to remove from the denominator, the exponent must be negative. Simple. Then here we simplify. It has to give us the answer. The cube root of 8, which is 2 times 2 times 2, then it's going to give us 2. And Yona, it's more like 18 over 3, which gives us 6. I'm simplifying. Exponent 18 over 3 is 6. There are numbers. Cube root of 8 is 2, because it's 2 times 2 times 2. It's 2 times 2 times 2. So this 2 to the power of 3. So it's 3 over 3, which is equals to 2 to the power of 1. That's where it comes from. Even if you have a calculator, you can do it. These things kids are grade 9, grade 10, so grade 9, grade 8. We cannot be redoing them in that manner. Okay. Going further, we will have here 3 over 4 x minus 2, and we can derive because it's simplified. We can derive. Exponent is 6, coefficient is 2, so times 6 minus 1. That's the first part. Second part, 3 over 4 minus 2. Exponent is minus 2 minus 1. I derived. I am done deriving, then I simplify. This one is 12. X, this one is 5. Negative times negative is positive. Then it's positive 6 over 4. And then x is negative 3. Exponent negative 3. Then I can remove this negative exponent into positive. Then I'll have 12x to the power of 5 plus 6 over 4. Okay. You're done. You have differentiated from that one. When you start to do these things correct, there's no longer need of talking. That's why you see that people who understand mathematics at high school level, they don't talk too much. When it's coming to maths, they don't even raise hands in the class when the teacher is asking questions, because the things are more interesting to them when they start to do and understand them. So if you don't understand this thing and you don't talk, you won't be having chance of being at peace. That's what we call it. The next one. Let me take this one as the last one as we wrap up the topic, and I'll give you more examples to work with. This one is more like everything comes differently, so but then it doesn't mean anything is changing. The law of deriving is the same that we use. X over 3 plus 3 over x, all in the brackets to the power of 2. Then the same thing, mathematics expand. We will have x over 3 plus 3 over x, part 1, part 2, x 3 plus 3 over x. We have expanded. Then what do we do? Mathematics says this one times this one times that one. And when I say 3 over x multiplied by, x over 3 multiplied by x over 3, then I will be having more like x to the power of 2 divided by 3 times 3 is, and then this one multiplied by the other one, it gives me 1. X over 3 multiplied by 3 over x, just the reciprocal of something when no matter is 1. And then the same thing, still plus 1. And then the last part, it gives me plus 9 over a power of 2. You see now they are swapping. It's 3 over x multiplied by 3 over x. So it's 9 over x. Then going further, I will have x to the power of 2, 9. X to the power of 2, yes, divided by 9. Write it, just rewrite it in this manner so that it can be understandable. So here is standard form. What do I have to do? Remove x from the denominator and then remove x here to be multiplying. So if there's nothing obvious is 1. If there's nothing obvious is 1. Then let's remove. If you can know these things before you derive, I'm telling you, there's nothing difficult here. So it's 1 over 9 x to the power of 2. If it's on top or as the denominator, as a numerator, like I said, you just remove it. Just remove that one that goes with that x as it is. Remove it, multiply everything. Leave nothing there. If there is nothing as given, it's a 1. Coefficient is 1, because anything multiplied by 1, it's 1. Nothing. So plus 2. Remove this one from here. Now I have 9 over 1 multiplied by x to the power of negative 2. Because I'm removing it from denominator, I multiply the exponent by negative. If I remove it from numerator, I just leave the coefficient of it. Derive. When I derive, exponent is 2. 2 multiplied by 1 over 9. Then x as x, then x minus 2. X to the power 2 minus 1. Then when I derive the number, a number is constant. We talked about this in the previous video. When you derive the number is constant. It becomes 0. Automatically, it becomes, there's no rule. It's just 0. And then this one, it's 9 multiplied by minus 2. Then x to the power minus 2 minus 1. So I will wrap the space somewhere here so that we can be having sufficient space to work on. I'll transfer this part up here. Then 2 times 1 over 9 be 2 over 9. Then x as x, then 2 minus 1 as an exponent is 1. Then 0, I leave it. So minus 2 multiplied by 9, it's minus 18. And then x as x, exponent of negative 2, negative 1 is negative 3. So now here I can change. How do I change? I return x back to its base, which is 2x divided by 9, then minus 18. I want to remove negative exponent, so what goes with x goes below. Then you have the right answer is this one. Thank you very much. Let's meet on the next video. Bye-bye. Please don't forget to subscribe on our YouTube channel and like the videos.